Okay, it says you have discovered that the equation y equals mx, so I want you guys to underline that. Y equals mx represents a proportional relationship. So here's one thing that I want you to know, that y equals mx is a proportional relationship. Now, the reason for that is, and over on the side here, I just want you to write b. Over here on the side, I want you to write y equals mx plus b, and then put b equals 0, so y equals mx. Okay? So the initial value is 0. Remember, b is what we call the y-intercept. It's also the initial value. All right? So for this y equals mx, our b value is 0. Now that's important because we're going to talk about going through the origin. So the initial value, the initial y value is 0.
Wait, what is that? Is that 0 equals 0?
No, that's a b. I'm sorry. This is a b. Okay. And then the equation represents every point x comma y on the graph of a line with the slope m that passes through the origin. So what I wrote here, b equals 0, is really the y-intercept, and the y-intercept is 0. So what that means is when x equals 0, my y equals 0. Okay? So now if we go on to read that, it says an equation of the form y equals mx plus b, where b is not equal to 0. So underline that. Y equals mx plus b, where b is not equal to 0, is or represents a non-proportional relationship. Okay? So if b equals anything other than 0, so over here put b does not equal 0. So when I have an equal sign with a slash through it, that's saying b does not equal 0. This equation represents every point x comma y on the graph with a slope of m that passes through 0 comma b. So now this is also what we call the y-intercept. So whenever x equals 0, whatever that y value is, we call that the y-intercept. And what that means is that's where it crosses the y-axis. So y-intercept is a formal math term that means crosses the y-axis. Okay? So then our questions, number 1 says, determine each graph shown. So if we slide up a little bit, I've got 2 graphs here. So remember that crosses the y-axis. So it says, determine whether the graph represents a proportional or non-proportional. Okay? So we've got to determine if it's proportional or non-proportional. So what we have to remember is, proportional means it goes through the origin. Non-proportional means it does not go through the origin. So if I look at graph A, does that go through the origin? Yes or no? No. So let's jot that down. Crosses the y-axis or the y-intercept. Where does that cross the y-axis at? B equals 20. So if B does not equal 0, what does that represent? Non-proportional. Okay, so that's non-proportional. Now, if I look at the second graph, go ahead, you can sharpen your pencil. If I look at the second graph, I see that it crosses the y-axis at the origin. The y value, in other words, my y-intercept, b equals 0, because that's where it crosses the y-axis. Y equals 0. So here, we see that the y value equals 20, and over here my y value equals 0. This point right here on the line is 0, comma 20. That's the y-intercept. This point over here is 0, comma 0. So it goes through the origin. So if it goes through the origin and it's a straight line, what does that tell us? It is a proportional relationship. So that's a proportional relationship. Now, we've got to guess what form it would have. Well, y equals mx plus b is going to be non-proportional, so this one would take the form of y equals mx plus b, and this one would take the form y equals mx and b equals 0, so we don't have to write it down. But now we got to guess what that would be. So m, remember m is the slope. It's the up and over. So I've got to look at this graph and I've got to figure out how many I go up and how many I go over. So the slope for this line is the change in y to the change in x. So at this point here, I go up 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to say 8. And I'm trying to get to this point here. So I went up 8, and then I'm going to go over 20, 40, 60. So 8 over 60. Now I've got to reduce that fraction. So I got to reduce this fraction. 4 goes into 8 2 times. So if I divide the top by 4 and I divide the bottom by 4, I get 2 over 60 divided by 4 is 15. So that is the slope of that particular line. So this equation for this graph would be y equals 2 over 15 x. And then what's my b term? 20. So we would say plus 20. Sit down. Now if we do the next one, we're going to do the exact same thing. So remember that your m, your slope m, is equal to delta y over delta x. So I'm going to count, and what you want to do is you want to find a spot where the line crosses the grid, okay? So I'm looking for, like, see this spot here? So now that looks like my line is crossing right on the crosshairs of the grid. So now if I look at that, my change in y, how much I go up? I go up 320, so that would be like my change in y, 320. And then I'm going to go over, that's like my change in x, that corresponds to 5. So I've got 320 over 5. Now remember, a fraction is just a division problem. So 320 divided by 5 is actually 64. So if I have y equals mx, I have y equals 64x. So I'm just substituting the 64 in for the m. So this is a non-proportional relationship because it has an initial value of 20. And this one over here is a proportional relationship because my initial value is 0. Goes through the origin. Okay?
You can wake up.
Okay, now I forgot about this graph C on the other side, but if we look at this, this will be a nice little recap. Right here is where it crosses the y-axis. That's at the point 0, 30. So right off the top, is this proportional or non-proportional?
Non-proportional,
Non-proportional, very good. Can somebody tell me why?
because it's not going to the orangey.
It doesn't cross the origin. So because it doesn't cross the origin, we labeled this as non-proportional. Now what that means is the equation is going to have a plus number at the end of it. Proportional. So I'm going to have something that looks like this. Y equals mx plus b. Now b has a lot of names. It's the y-intercept. Okay. It's also what we consider the initial value. Okay. So if I want to find this equation, I need to know what the b is, and I need to know what the slope is, m. So b then is this term right here. In other words, b equals 40. So I'm going to plug that in. I'm going to say y equals mx plus, or not 40, 30. Okay? Because that's where it crosses the y-axis. Right here at 30. Now, to find m, I'm going to say that m is equal to the change in y over the change in x. Remember, this little triangle is the Greek letter delta, and it means change. Okay? So now to find that, I'm going to look at my graph very carefully and try to find a place where the graph crosses at or around on the grid. So I'm going to choose that point. So now if I'm going from 30 to 45, if I want to go up, I would say 45, because I'm starting at 30 and I'm going up to 45. I would say 45 minus 30. Okay? What is 45 minus 30? 15. So I would put 15. Now I'm going to go from here all the way over to here. So that would be 12. Now that's what I'm guessing. I don't know, you know, the Carnegie's answer or solution book has slightly different numbers, but that's okay. So now I can reduce that. Both numbers are divisible by 3, so I'm going to divide this by 3 and divide this by 3, and I get 5 over 4. All right, so then I could say that this is y equals 5 over 4 x plus 30. Does that make sense?
Yes.
And we said it was non-proportional.
Yes, sir.
All right. So now, here's an interesting one. Question number 2 gives us a different graph. And it says, determine the slope of this graph and write the equation to represent it. So this is interesting. I'm going to try to figure out what the graph, this graph is. So the first thing I could do is figure out, where does it cross the y-axis? Well, it looks like it crosses the y-axis at 0, 5. So now if it crosses at 0, 5, what is the y-intercept? 5. So b equals 5. So that means I'm going to have an equation that looks like this. Y equals mx plus b. So I know what the b is. Now I got to figure out what the slope is. So the slope m is equal to the change in y over the change in x. So from here, to get to another point on the line, how much do I go up or down? No. From here, how much do I go up or down? No, I don't go up or down. What's a number that represents no? Or Nothing.
0.
0. So my change in y is 0. Now my change in x could be 1, it could be 2, it could be 3, it could be 4. What's 0 divided by any number?
0.
0. So my slope is actually 0. So now I take this equation, leaving the y's and x's alone. I plug in 0 times x plus 5. Now it doesn't matter what x is, because whatever I multiply by 0, what will it always equal?
0.
0. So this term will go away. This term goes away, and I'm left with y equals positive 5. Do I need to write down the plus sign, or could I just write 5? 5. So now you don't know this, but all vertical line, or not vertical, all horizontal lines look like this. Y equals whatever the y-intercept is. Okay? So if you have a horizontal line, you really just need to figure out where it crosses the y-axis and then say y equals whatever the y-intercept is. Okay? All right. Now what they wanted us to do, shh, be quiet, they wanted us to describe a situation that could be modeled by the graph. So think of a scenario that no matter what, it will always equal 5.
1 times 5.
I'll give you an example. So we're comparing, let's look at this. We're comparing the number of hours and the number of miles. So what does that mean? If I'm at 5 miles, miles is a distance. But over time, I don't move at all. So think of a scenario in your head that could be represented by this graph. How about Mr. Adams came to school today and he parked his car in the parking lot, and I was here for 8+ hours and my car never left. So let's assume that I live 5 miles away from my house. So I would be 5 miles away from my house all day long. Does that make sense? Okay. I'm not going to write that down because we don't have room, but I want you to think about that, because these numbers represent real life scenarios. So number 3 says complete the table of values to represent the linear relationship specified. So if this is a linear relationship and it is proportional, it takes the form of y equals mx. So now what that means is I'm going to plug in a number, and I have to figure out, I basically, to write this equation, I need to figure out what m is. Now you don't remember this, but a couple worksheets back, we discovered that you can find m if I divide both sides by x. So m equals y divided by x. So I only have these two x and y values. So now if I say m equals y, what's my value for y? Yeah, you shouted out the answer, but don't get ahead of me. So that would be 12 divided by 2, which equals 6. So my equation is y equals 6x. So what that means is I'm going to take and multiply my x value by 6. So if I take my calculator out and I go 6 times 0, what do I get? 0. 0, right? So now if I take 6 times 1, I'm plugging in the x values. What do I get?
6.
6 times 1 is 6. So this next one is
12.
6. We're going to skip and we're going to say 6 times 3. 18. And then 6 times 4. 24. Now, what we could have done is we could have gone in here and just said 6x. And then look at the table of values. And we would have got the same thing. Does that